Hey students, welcome to class. This is Mrs. Brunk. We're going to be continuing our work with extending trigonometry past the right triangle, and today we're going to be learning about the law of cosines. So let me remind you, our most recent lesson we learned the law of sines, and the law of sines is something that you can use, a relationship that you can use in any triangle, even right triangles, although we rarely will use them for right triangles because we have the sine, the cosine, and the tangent. But we used them in instances where we didn't have a right triangle and we had certain conditions that we could meet in the triangle. And we wanted to find, say, angles or sides. And the condition we needed was to, at a minimum, have an angle side pair where we knew both of them. And then the law of sines allowed us to write a proportion that we could use to find either a missing side or an angle. But what about if you don't have that condition? So if we don't have that condition, we need to have some kind of alternative for that, and that's where the law of cosines comes in. So the law of cosines can be used to find a side or an angle, just as the law of sines could be, given two sides and the included angle, in other words, the side angle side condition, or if you know all three sides. So obviously if you know all three sides, you're not going to be using it to find a side, but that would be the condition if you wanted to find angles. So if you want to find angles using the law of sines, you'd need to know the length of all three sides. If you're wanting to find a side, you're going to need to know two sides and the angle that's across from the side you're looking for. So the law of cosines is usually given as three different statements, different relationships, but really they all come back to, really it just as how we name the sides, like the letters we use to name the sides. So even though if you look up the law of cosines, you'll usually see it stated three different ways, I usually just focus on one, and it's one that looks a lot like another relationship and you see if you can name the one as I start to write the law of cosines. So the law of cosines says this: c squared is equal to a squared plus b squared minus 2ab cosine of c. Now, of course, I'm sure you noticed that this first part, c squared equals a squared plus b squared, that's Pythagorean's theorem. And in fact, that's actually where the law of cosines came from. It actually is starting with the assumption that the triangle is a right triangle. And then this final part of the law of cosines, the minus 2ab cosine of c, is basically like a little adjustment that takes into account that the biggest angle of the triangle is not 90 degrees. It might be an acute angle. It might be an obtuse angle. And in the case of, say, you had an acute angle, the side across from it would be smaller than it would be if it was across from a 90-degree angle, and vice versa with an obtuse angle. And so the minus 2ab cosine of c just takes into account that the angle is not 90 degrees, but it also does work for a 90-degree triangle. And it adjusts for that fact. And that's the one that's used to find sides. Now, the other versions you'll see of that would just be from the other side's perspective, because it doesn't matter which side you're looking for. You just always call it c. But they would say like a squared equals b squared plus c squared minus 2bc cosine of a, and so on. So, I mean, like, they're just whatever side you're looking for, there's a version of it. Now, the big thing that you'll notice that's true about each one of the versions that you might see is that whatever side you're looking for, you know the other two sides, and then you need to know the angle across from the side you're looking for. So that's why I'm saying I just use really just one version, and I just use the one that is the most like the law, or the Pythagorean's theorem, because it's just easier for me to remember. And now this is the one you're going to use if you're finding sides. So whatever side you're looking for, because of course you'll know the other two sides because you need them to find any third side, then you're going to use this one, and you'll call whatever side you're looking for, that you'll kind of refer to that as like your c, or your c squared. So we're going to go ahead and take a look at finding a side, and then we'll come back and we're going to add to our formulas here. We're going to look at a different perspective on the law of cosines if we're trying to find an angle. So let's take a look at example number 1. Here we're trying to find this side called x, and so that's what it's going to be, like our c squared. So we're going to say x squared is equal to, well, we need to know the other two sides, and they're 23 and 9, so it doesn't matter which one you put first. 23 squared plus 9 squared, or 9 squared plus 23 squared, minus 2 times 9 times 23, and again, order doesn't matter because we're multiplying, and then times the cosine of the angle that's across on the side we're looking for, and of course that's 71 degrees. And so essentially this is not even an equation to solve. We know every single thing on the right hand side here. It's just a matter of doing the calculation. So sometimes people will take 2 steps to do this. They'll figure out what the 23 squared plus 9 squared minus, all that. They'll do that first, and then they take the square root. But with our graphing calculators, we really can just do it all at once. So you could just go ahead and take the square root of and make sure all of that is underneath the radical, whether that means you got to put parentheses around it or not, depending on how updated your calculator is, and it should tell you directly what the length of that side is. So I'm going to pause the video now for a second. I'm going to quick do that calculation, and we'll find out what that missing side is. And I'd like you to do the same because you want to make sure you're typing these in your calculator correctly. So go ahead and pause the video now and find out what the length of side x is. So my calculation came up with about 21.8. 21.8, which if we look at the triangle, that makes sense with the given other sides, 23 and 9. So 21.8 is the missing side. And we'll go ahead and set one more up together, and then I'll give you one for you try. So again, with this one, we're trying to find this side. And again, that's what we're going to call c, so that's x squared is equal to 15 squared plus 17 squared, or 17 squared plus 15 squared, minus 2 times 15 times 17 times the cosine of 39 degrees. Now, before we actually do this calculation, I want to just explain a little more why this works. So when you think about the cosine of 39 degrees, if you just typed in the cosine of 39 degrees, you're going to get a positive number. So if this is something that's positive, this is positive, this is positive, this is positive, right? When you multiply all these things, it's going to be something positive. And so you're going to be subtracting that from 15 squared plus 17 squared. And that makes sense because basically, if the biggest angle in the triangle is not 90 degrees, it's something smaller than that, the side across from that would have to be something smaller than what the hypotenuse in a right triangle would be. And so that's really what's happening, is this end part is really just subtracting off the excess length that this side would have, so because it's got a smaller angle across from it. Whereas let's say we instead had an angle that was bigger than 90 degrees, say instead of 39 it was like 102 or something like that. The cosine of something like that is going to be a negative number, and then that's going to end up being subtracting a negative here off the end. So this whole thing will be negative, this stuff right here will be a negative number, right? Oops, this will be a negative number, so it will be minus a negative, which makes it a plus. So then we'd be adding on to the 15 squared plus 17 squared to make it a longer length side. So again, that's kind of how it takes the Pythagorean theorem as a basis and extends it out to other non-right triangles. But let's go ahead and again, I'll have you pause the video. We'll go ahead and try it in one step. We really don't usually need to pick this apart. Sometimes I see more mistakes when people try to do it in pieces, or they'll forget to square root at the end. So I usually just try to put it in all at once, just make sure it's all actually under the radical, whether that means you need to parenthesis it or whatever. And let's tune back in and make sure we get the same thing. So pause the video now. And I got 10.8. Hopefully you did as well. And that's definitely a very reasonable length for that to be, and definitely in line with the 15 and the 17. And certainly the two angles across from 15 and 17 will be bigger than 39, and so it makes sense that this side would be 10.8. But otherwise, there really is no way to technically check it because, again, this is not a right triangle, so you can't go back to Pythagorean theorem to check it. But all right, we're going to give the next one as a you try question. So let's take number 3. And actually, I'll help you draw the triangle first. Let's do that first and make sure that's all set up, and then you can calculate that on your own. So we've got a triangle ABC. Angle B is the one that's given. I just drew this because I saw that it said angle B was 106, so I wanted to make a pretty big angle in it. And then I'll just call this side A, and this angle A, and this would be C. So then AB is 10, BC is 7, and they want us to find AC. So we're going to call that X. So now you got your setup, and you can use your law of cosines to find the missing side. So go ahead and pause the video now, set this up, find the length of side AC, and tune back in to check your answer. All right, thanks for giving that a try as your you try question. Oops. And hopefully you were successful in finding that the length of the side was 13.7. And that's definitely a reasonable length. It must be longer than 10 and 7 because the angle is the biggest angle in that triangle, 106. Okay, so now we're going to move on and take a look at what do we do when we're trying to find an angle. Okay, so what happens if we want to use the law of cosines to find an angle? Well, you know, the law of cosines looks like this. C squared equals A squared plus B squared minus 2AB cosine of C. And if we wanted to find an angle, and we would want to consider it to be C because, of course, that's the only angle that's actually in this formula, is angle C. So in this case, say, for instance, this would be angle X. Then what we would have to do to use this formula, the way it currently is we would have to put in the side across from the angle we're looking for first. So that would be 8 squared equals, and then the other two sides, it doesn't really matter. You could put either one in first. And that would look like this, and then we'd have the two sides that are on, considered the A and B, okay, and then cosine of C. So we know that if we're trying to find, which actually now this is called cosine of X, we know that if we're trying to find an angle, we're going to have to use an inverse. So we know that. But this now, instead of this being just something to evaluate, like it was when we were finding a side, we just typed the whole thing in our calculator. This is actually something we would have to solve, and it's actually pretty in-depth because what we'd have to do is figure out what all of this stuff is right here, right? What these things are, we'd have to subtract them from the other side. So, like we'd have to take whatever 11 squared is, subtract it from whatever 8 squared is, take 10 squared away from whatever that is. We'd have to figure out what this part was, which ends up being like the coefficient of cosine of X. And then we'd have to divide both sides by it. So, I mean, this is what it would look like. If we had to use, I'm going to show you another formula, but just to kind of show you how the way it's set up, the current way, it would be difficult to do. So we've got 11 squared, which is 121, and 10 squared, which is 100. If we add those together, that's 221. 8 squared is 64. If we multiplied 2 times 11 times 10, let's see, we get 2 times 11 times 10. That's going to be 220. And then cosine of X, so we don't know. So in order to solve this, what we'd have to do is we'd have to undo this to get the cosine of X by itself, and then take the inverse. So we'd have to subtract 221 from both sides. Okay, and again, I'm going to show you a little easier way in a minute, but just for now, just to kind of show you the way it's set up to be used. And I got a negative 157, and then that equals negative 220 cosine of X. And then I'd have to divide both sides by negative 220. and then negative 220, and that would give me a, let's see, 0.71363636, then it repeats, so 7136 is equal to the cosine of x. And finally we're to where the cosine's by itself, so now is where we would do that inverse cosine, and that would tell us our angle. It's inverse cosine of 0.7136, and that's going to tell us our angle is about 44.5. So it's about 44.5 degrees. So now that's a lot of work, a lot more work than it is to find a side, because the formula is tailored to find sides. So that would actually be the process we'd have to go through pretty much every single time we want to find an angle. And so finding an angle with law of cosines in its current state would be pretty difficult. So instead of doing that every single time, why not just rewrite the formula and use a formula that's specifically tailored for angles? And that's exactly what we did. You won't always see this. You won't see this probably in our textbook. I've seen it a few places. But really I have to attribute it back to a student I had long ago who we had done enough of these that he finally said, well, why do we not just rewrite the formula and use a different formula? And I thought, well, that's genius. And that's mathematics. We always want to try to do things more streamlined, more efficient way. And so we're going to take a look at what that formula would look like from the angles perspective. So now if instead I wanted to rewrite this so that this part was by itself, okay, what I'd have to do is subtract the a squared and the b squared. So what that would look like is it would be c squared minus a squared, and we'd also have to subtract the b squared, so minus b squared. But then we'd have to divide that all by this coefficient of the cosine of c, which is the negative 2ab. And then once we did that, all that would be left on the other side would be the cosine of c. And that actually is the version of the law of cosines that we're going to use when we are trying to find angles. So moving forward, instead of having to go through all of those steps that we just went through to find that this angle was 44.5 degrees, we're instead going to use this new version, and that'll just kind of streamline things. So instead of solving an equation every single time, we're really mostly just going to be evaluating the one side because we'll know all the inputs because we know all the sides, and then all we'll have to do is take the inverse cosine of both sides. So let's go ahead and instead of redoing this one, although it would be a good idea to redo this one just to make sure we get the same thing, which we will, we're going to go ahead and go on to question number 5, and we're going to use our new formula to find the next missing angle. So here's the missing angle. We're trying to find this angle x. So when we write that formula, it's a good idea to rewrite it a couple times just so you get used to the formula. So that's cosine of c equals c squared minus a squared minus b squared all over minus 2ab, or negative 2ab. And so specifically though, because whatever angle we're trying to find, if we call it c, that side, notice, only appears one time in the formula. That's the very first side. So that's really important that you get the side across from the angle that you're looking for in that first spot, and then that's the only place it appears. So in this particular problem, we'd say the cosine of x is equal to, well, the side across from x is 16. So that's going to be the number that goes in first. So 16 squared minus, and then either one can go next, 5 squared or 13 squared, all over negative 2 times 5 times 13. So notice again, we didn't use the 16 again. We used it just one time, and it was across, because it was across from the angle we're looking for. So this is one, like with our law of cosines for sides, we could pretty much do it all in one step, all in the calculator. With this, you definitely cannot. You need to break this down and do a couple steps to solve this. So first of all, you want to figure out what the numerator of your fraction is. So that'd be the 16 squared minus 5 squared minus 13 squared, and that turns out to be 62. So my numerator is 62. My denominator is negative 2 times 5 times 13, which is negative 130. And now we're to the point where we can do the inverse cosine of both sides. So we can do the inverse cosine, and the inverse cosine of 62 divided by negative 130, and make sure you put that in parentheses like that. The 62 divided by negative 130 has to be in parentheses, just like this. Type it in exactly how I have it here, and that should tell us what our angle is. And when I did that, I got approximately 118.48, so about 118.5 degrees to the nearest tenth. And that is definitely a very reasonable number given the triangle that we have here. That's 118 degrees. Now, the really nice thing about the law of cosines, unlike the law of sines, remember with the law of sines there was the ambiguous case, and there were potentially two different possible answers when you're finding an angle. With law of cosines, there is not that situation. And the reason for that is, if you remember back to the unit circle, with the sine, the sin, the sign was positive in the first quadrant and in the second quadrant. In other words, anywhere from 0 to 180 degrees for angles. Whereas with the cosine, it's positive from 0 to 90, and in that second quadrant, remember the cosine was negative? And so that's already going to take care of itself within the law of cosines, because cosine will, if the angle is greater than 90, it will give you a negative value there and take care of it. Let's go ahead and try another one. So this time we don't have a triangle drawn, and so it doesn't really matter as far as like, you know, what our drawing looks like. Remember, it's always just about orientation of things. So if I wanted to draw this so it looks, you know, fairly accurate, I guess. I mean, at least as accurate as I can, given that I don't know anything about the angles, is I would make the longest side be 24, which looks like that, and so because that's ln, let's see, this would be L, and this would be N, and then if mn, that would be M here then, and this would be 20. Oops, I probably should have made this. Yeah. Actually, I saw that LM is 25, so let me fix this. So let's see, make this the longer side. We'll fix this up. So actually the longest side was 25, so that would have been LM, make this M, and then make this one N, I guess. Although, again, it doesn't really matter. This is more for just our reference. So if that's LN, then LN would be 24. Okay, see, then this still is going to make this the smallest, so it doesn't really matter, and MN is 20. But we're trying to find angle L, so of course angle L would be across from side NM, because it doesn't, you know, share the same letter. So that's how we know these are across from each other. So we would say the cosine of L, which is the angle we're looking for, is equal to. So then we want to make sure we put in 20 as the first side, and that's the only place it's going to appear. The other two sides, the 24 and the 25, can go in either spot. And then on the denominator, the negative 2 times 24 times 25. And now we got to take an opportunity to figure out the numerator and denominator. So the 20 squared minus 24 squared minus 25 squared is negative 801. And the denominator, negative 2 times 24 times 25, is negative 1200. And that final step then is to get rid of the cosine so that we just have L, and so we're going to do the inverse cosine of that 801, inverse cosine of negative 801 divided by negative 1200 gives me about 48.1 degrees. So about 48.1 degrees. And if you think back on the triangle, that makes sense because this is definitely the smallest side, so this angle should be the smallest angle, and 48.1 is a smaller angle. So for our final part of the lesson, we're going to take a look at some applications, and we're going to look at how we might use the law of cosines in some real-life situations. Example number 7. Maple Street, Oak Drive, and West Avenue intersect to form a triangular piece of land. So we've got these 3 streets. The angle formed by Maple and Oak. So let's say we call this one Maple Street. So Maple, we'll call this one like Maple. And let's say we call this Oak Street. Oops. And then we call this West. So it says that the angle formed by Maple Street and Oak Street is 79 degrees. Well, again, I did not make a very good drawing based on the angle, but again, this is just for our reference, so it's fine. It is what it is. So this is 79 degrees. And it says if Maple Street section of the triangle is 390 feet, so this is 390, and the Oak Drive section is 250. Find the length of West Avenue. Okay, so this is our just using the law of cosines to find a side. So remember, this was the easy one. We can just say West Drive, or West squared, is equal to the square of the other 2 lengths added. Again, either one can go first. Oops, that's not supposed to be degrees, sorry. That's supposed to be squared. And then minus 2 times the product of those numbers. Oops. And the cosine of the angle that they form. And I'm running out of room, so times the cosine of 79 degrees. So remember, when you're finding a side, you can easily do this all in one step. So we just go to our calculator, and if you want to pause the video now, I'm going to pause and calculate this. You can do the same and just make sure you're getting an accurate value when you type in your calculator. So go ahead and pause the video now, and we'll find out how long West Avenue, excuse me. So I got that West Avenue was approximately 421.2, and the unit was feet, so it's feet long. So 421.2 feet. Let's look at number 8. So Jack and Tom start at a tree, So they started a tree, and beginning run apart with an angle of 23 degrees between them. So angle is 23 degrees. There's the tree. Let's say we call this T. We can't use that because they're going to use Tom. We have Tom and Jack. So Jack, so let's say this is Jack, and this is Tom on the other side here. And they're running away from each other towards, in an opposite direction, 23 degrees between them. If Jack runs 50 meters, so Jack's running 50, and Tom's running 38, so we know what these lengths are, and they're meters, find the distance between them. So by the time they go out, one goes 50 and one goes 38, how far are they apart? They're wanting to know this length right here. So there's another law of cosines to find a side. So I'm actually going to try this one going straight to my calculator. So I'm just going to do the square root of 50 squared plus 38 squared minus 2 times 50 times 38 times the cosine of 23. So just put it all in my calculator all at once, and I got approximately 21.1 meters. So they're 21.1 meters apart. And what you'll find is the more you use the law of cosines for sides, you may get to a point where you don't feel like you even have to write anything down, and you can go straight to the calculator to find out that length. Now, Definitely not the case with the angles. There's a little more involved there. And so, that you'll probably have to still break that up and do it in parts. Let's look at the final example to wrap up this lesson. So this one, again, is just a triangle that we have to create. We don't really know exactly what it looks like, but to create our stations 2.5 miles apart, are tracking an airplane. The straight line distance between station A and the plane is 7 miles. So we've got like an A, and let's say the other station is B, which is what it says. And they are 2.5 meters apart, or miles apart, sorry. And then there's station A is, so there's a plane out here, say the plane's right up here, say called P. And it says that station A and the plane are 7 miles apart. And it says the straight line distance between station B and the plane is 9 miles apart. So this is 9. What is the angle of elevation from station B to the plane? So what they're asking for is this angle right here. They're asking for the angle of elevation from B to the plane. And so we're looking for angle B, in other words. So then we would say the cosine of B is equal to, and of course we want to have the side across from B go in first. So that's going to be the 7. So 7 squared, and then as far as the other two go, it doesn't really matter. So 9 squared and minus 2.5 squared, going to be your numerator. On the bottom it'll be negative 2 times 9 times 2.5. So remember, the side across from the angle you're looking for goes in first, and then that's the only place it appears. So now what we need to do is figure out the numerator, figure out the denominator, and then we can do the inverse cosine. So that numerator is 7 squared minus 9 squared minus 2.5 squared, and that's a negative 38.25. And the denominator is negative 2 times 9 times 2.5, which is negative 45. And remember, that's what the cosine of B equals, so to solve, we're going to take the inverse cosine. Inverse cosine, inverse cosine, and that'll tell us our angle. Inverse cosine of negative 38.25 divided by negative 45 is about 31.7883, so about 31.8. And that does it for today's lesson. So I hope you enjoyed learning about the law of cosines. And in the next lesson, we're going to combine the two, law of sines and law of cosines, and you're going to have to figure out which one you have to use. But for now, you're going to be looking at problems in your practice set that revolve around the two different versions of the law of cosines. So good luck. Take care.